In this video, I'm going to be discussing inverse trig functions, their domain, range, and how to use them in particular situations. So when we're looking at inverse trig functions, there are three that we primarily talk about: sine inverse, cosine inverse, and tangent inverse. Now the whole goal of the inverse functions is to input a ratio and to output an angle. That's the ultimate goal, and we use this to solve problems where we know the sides of a triangle and we want to find the angle that is inside of it. Now, just a review of our sine inverse. The domain here, is between +1 and -1, meaning I can only plug in those values. And the reason for that is, if you remember, we're plugging in a ratio, and the biggest sine value we can possibly get is 1, and the smallest we can possibly get is -1. So that's why our domain is the way it is. Now the range here is between pi/2 and -pi/2, meaning that sine inverse will only give us angles between -90 degrees and +90 degrees. Now we limit this because if we didn't have a restriction, this wouldn't be a function, because there are an infinite number of answers to trig functions. For example, there are an infinite number of angles that have a sine of 1/2. So if we don't limit it, we'd have to list them all, which could be a pain. Now cosine inverse has the same domain, is between -1 and +1. But the range is a little bit different. It's between, y is between 0 and pi, meaning it will output angles between 0 degrees and 180 degrees. Now tangent here, the domain of tangent is all real numbers. You can plug in any number into tangent inverse and you'll get out an angle. However, the range here is the same as sine. It is between -pi/2 and pi/2. Now the reason that I'm spending some time reviewing domain and range is because what happens when we get to something like this? Let's say we're asked to find sine inverse of 1/3, and then something to the side like this is given. So I'm asked to evaluate sine inverse of 1/3, and I'm supposed to find an angle between pi/2 and pi. Well, if I'm looking at my range here, my output values, I know that sine inverse will only give me angles between -90 and +90. However, the problem here is asking me to give an angle between +90 degrees and +180 degrees. And so the question then becomes, how do I use sine inverse to find this angle? Now this is going to be very useful once we get into some physics applications, but we're going to keep it kind of conceptual for right now. So the way I'm going to handle this is I'm going to start with a picture to kind of illustrate what I'm doing. So I'm going to start here using my calculator. I'm going to evaluate sine inverse of 1/3. Now just a suggestion, when you're doing this on your calculator, I suggest putting it in degree mode, because I can work a little bit easier with degrees than I can radians, specifically in a calculator. So I see here that my angle is approximately 19.5 degrees. So 19.5 degrees. And this is in quadrant 1. Now 90 degrees to 180, this is quadrant 2. This implies my answer has to be in quadrant 2. So I have to find an angle that has the same sine value, but is located in quadrant 2. Now here's how we do it. 19.5 degrees ultimately becomes our reference angle. If you remember back to evaluating trig functions, angles that have the same reference angle, at least we use them with the same reference angle to evaluate the trig functions. They don't always have the same, but they're really close, meaning that the signs will be flipped or so on. So my reference angle here is going to be 19.5 degrees. That's my reference angle. So that means I'm looking for that angle right there. So what I'm going to do here is I'm going to subtract. This whole thing is 180. So I'm going to take 180, I'm going to subtract 19.5, and the angle I'm looking for is 160.5 degrees. Now if I want to check it, I can, in my calculator, type sine of make sure I can think right, 160.5, and it should come approximately 1/3, 0.3 repeating. And that's pretty close. Now remember, I rounded earlier. If I went out to all the decimal places, it would come out to be exact, but I'm not going to be that detailed. So the angle we're looking for in this case is 160.5. Okay, let's try another example. So let's say I'm asked to find, let's say I have cosine inverse of, let's say, negative 0.45, and I'm asked to find an angle that is between pi and 3 pi over 2. So I need to find an angle that has a cosine value of negative 0.45, and I need to give the answer between 180 degrees and 270 degrees. So again, I'm going to start here with a picture. So let's see, let's evaluate. So cosine inverse of negative 0.45 comes out to be 116, we'll do 116.7. So over here, we've got 116.7 degrees. Now this one is a little bit more difficult because here I have an angle, it's between 90 degrees and 180 degrees. But what I'm looking for is I'm looking for an angle between 180 and 270. So ultimately I'm looking for a quadrant 3 angle. So this is where we're going to have to play around with it a little bit. Since this is bigger than 90, I'm going to have to calculate the reference angle. And if you notice, we did that in the last problem, but 19.5 is its own reference angle, so I don't have to do anything crazy there. So I'm going to calculate the reference angle. So I'm going to take 180, I'm going to subtract 116.7, and so my reference angle is 63.3. So what I'm going to do is I'm going to use my reference angle, but I'm going to put it in the third quadrant. So my reference angle is 63.3. And now I have to find the angle that when I start here and go all the way around to this orange line, or this orange angle, it has a reference angle of 163.3. So to do that, I do 180 plus 63.3, and I get 243.3. So my angle is 243.3. Now I'm going to check it. So when I check it, I'll do cosine of 243.3. It should come out to be really close to negative 0.45. So cosine of 243.3, and it's approximately negative 0.45. So you have 0.449. That's pretty darn close. So I'm saying I'm good. Let's do one more example, but this time I'll use tangent. So let's say I have a tangent inverse of, let's make it 2. And this time I'm going to say I want this to be between, let's see, negative pi and negative pi over 2. Let's make it a little different. Now before I really start digging into this problem again, I want to look at where is my solution supposed to be. So remember, this is negative 180 degrees and this is negative 90 degrees. So on a coordinate grid, if I draw the picture, negative 90 to negative 180, that is over here. I'm looking for an answer in this quadrant. So this implies I'm going to give a quadrant 3 answer. However, I have to make sure that I give my answer as a negative. We'll deal with that in a moment. So let's go ahead and evaluate tangent inverse of 2. So I get a value of 63.43. Make sure you can see it there. So my angle is 63 point, well, let's make it 0.4 just to round a little bit. So that's what I get when I evaluate tangent inverse. Now, ultimately, this is going to be my reference angle. So I'm going to go ahead and drop my reference angle into this quadrant. So this would be 63.4. Now, this is obviously not to scale. Now, the trick to this problem is I have to figure out a negative angle. Notice I'm asking for a value between negative 180 and negative 90. So what I'm going to have to do is I'm going to have to work backwards. So starting here and going negative, I have to figure out what this is. Well, here's how I do it. I take 180, I subtract 63.4, and so I know that that angle is 116.6. So to make it negative, I just make this negative 116.6. So my angle is negative 116.6. And let's go ahead and check it. So tangent, negative 116.6. So tangent, negative 116.6. And I get really, really, really close to 2. So really for this whole process, we're simply looking for the reference angle. As we noticed, we had to calculate the reference angle in all of them. We're going to put our reference angle in the quadrant we want, and then find the angle that matches the condition. So in this case, I had to find a negative angle, so I made a negative. In this one, I had to find a positive one. Notice these are positive. And same thing here. So find the reference angle, put it in the quadrant, find the angle. And that's how you evaluate inverse trig functions and find answers or find angles that fit specific conditions.